Okay, everybody. Let me make sure my mic is working. Yes, it is. Okay, so we are now going into the nervous system. Now, nervous system is a really in-depth system. So we split it up here into four parts. Your nerves are how you feel everything, and we're going to be starting here with small, which is just how is it organized and what is a nerve even. So we're starting small before we apply this into other things. For example, like the thing that makes that really just helps you run, dopamine, and tolerances, and your senses. How do those all work? So that's where we're going with this. Now you can see here, this is a circulatory system. This is your blood system. We'll be covering this later in the class. But this here is a nerve system, and this is a real human here. This is a human's body. This has only been done about 5 or 6 times. You can see the actual nervous system in place here. I took this photo. I've seen this. Um, so one thing I quickly want to highlight here, and this will come into play a little bit later, I like referring to this is your nervous system. Look at how it's arranged. You have your brain, you have your spine, and then you can very clearly see, oh, here's the legs, here's the arms, and then these all must go somewhere within there, right? So your nerves are shaped in your body, right? They're everywhere. Then we do have some essential questions, which we'll cover a little bit later. So we are covering parts 1 and 2 here, okay? Parts 1 and 2. You should have read the textbook before you jumped into this video. This video is meant to give you context because the textbook is really, really deep and detailed, and it doesn't always click well, right? So if you haven't yet, watch any previous video before this, read the textbook section, complete the worksheet here as you read that textbook section to the best as you can. It's not graded, but we do use that stuff for quiz questions later. Okay, so what are neurons? Now, these are specialized nerve cells. They're split up into 3 different regions, right? So you can see here we have our cell body, which is composed of a couple things. We have dendrites, it has a nucleus in it. We have an axon, and then we have axon endon. So dendrites, cell body, axon. These dendrites here, these little, like kind of like spider webs, those are what get those impulses. Where's my video here? So for example, I have my video here. This is hot coffee. If I were to pour this onto my finger, it would be the dendrites in there, those little spider webs that would be getting that information and sending that to the rest of my body. Like, oh, wow, that coffee, it burns. Ah. So that's what these do. So dendrites get the impulses, they send it to the cell body, and then that's going to send it along the axon, which is kind of like a highway, to the other things in your body, to other nerve cells, other neurons, sorry, and to your muscles and to your brain. So you make sure you pay attention to this example here. This is an example in your textbook, and I'm gonna simplify this as best I can here in a bit. So, but you have 3 kind of neurons. You have a sensory neuron, an interneuron, and a motor neuron. Sensory ones are what send those impulses from the receptors, and they send that to your brain and your spinal column. Okay, so if I go, bam, I stub my toe in the foot. Oh, shoot, that hurts. That is my sensory neuron sensing that. It's going to take that pain, that, oh God, that hurts. It's going to send it into my interneuron, which is in my spine, which shoots up to my brain. And then my brain's going to, it's going to eventually tell me to kick your leg back and swear a bunch, but it'll get a little more complicated than that. So those interneurons carry those impulses to motor neurons. Now, I really want to make a distinction here. Impulse, reflex, when you hold a hot pan, when you stub your toe, when I throw something as hard as I can at your face, your brain doesn't make a decision there. You don't consciously decide to kick your foot back, drop the hot pan, try and block your face. No, that's an impulse from your motor neuron. In this incident here, my leg has moved independently. It independently, automatically moves the foot back. Okay, so it goes up into the spinal column, and then it does 2 things. One, it goes into the brain, and 2, it also goes into my motor neuron to move my foot back. It's the same thing if I throw something at you. You're going to instinctually, reactively, maybe try and block it or cover your face, whatever it is, right? Have any of you ever driven on the road in winter and you see a deer or a moose or something on the highway? What's the worst thing you can do in that situation? It's slam on your brakes and turn the wheel as hard as you can, isn't it? Because you're just going to end up rolling into the ditch. Much deadlier than as if you just slowly moved your steering wheel. So you had an impulse, a reaction, versus the logical part of you might have a different reaction. So that's where that comes from. I'm going to come into this example here in a second again. So again, sensory neuron into my interneuron. Now that signal does two things. The first thing it does is it goes into my motor neuron here, which is going to tell my foot to kick back. We call this a reflex arc. Okay, reflex. It's a reflex. So it goes sensory neuron, interneuron, motor neuron. Ding, 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 ding. You have a reflex arc. You have a reflex. Now, that said, motor neurons can also be told what to do from your brain and your spinal cord, right? So we can get signals from two different ways. So how does this happen? Well, if I stub my toe, my sensory neuron gets the impulse and it sends it to the brain and the spine. Now, my involuntary reaction will be to feel pain and move my foot back. That is a reflex arc, okay? At the same time, sorry, how that happens is it sends that signal to the motor neuron to your leg to move before anything else happens. But at the same time, that signal's also going to your brain, which is then going to process the pain, process the information, and then make a decision that you voluntarily act on. Okay? Now, have any of you ever seen this in a movie where they're little kid on the table, doctor has a little hammer, tap, 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 tap the knee? That's triggering a reflex arc. It's seeing how the reflexes are. You don't consciously decide to just kick your foot up a little bit. It just happens. So we have here something that we call an action potential. Now I'm going to actually reword this a little bit into, here's my pen. We call this an all or nothing response. So that's an easier way to think about this. So it is, the official term is called action potential, but I think of it as all is nothing. And I will come back to that in a second here. But this is the minimum stimulus to cause an action potential to be produced. That's what we call a threshold. Now, your nerve impulse is either activated or it is not. It's not half-assed. It's either activated or it isn't. Okay. Now, one way to kind of think about this here is if you put your hand into some like room temperature water, you haven't really activated any nerve impulses. If you were to stick your hand into freaking hot boiling water, oh, geez, you've activated that action potential. It's gone past that certain threshold to where your cells actually feel it, send a signal to your brain and go, hey, what are you doing with your hand? Something's happening here. Pay attention to it. It's the same thing as if, maybe right now you're in this video. Did that wake you up a little bit? It's the same volume, isn't it? I just went from talking to clapping. Why did one alert you a little bit more? Why did one perk you up a little bit more? Well, it stimulated more of an action potential, more of a threshold. You can get used to certain things. I live across from the train tracks. I don't notice when the train comes anymore all the time. If you're new to my house, though, oh boy, you will notice it. So you can get used to things. This comes into play a little bit later with tolerances and stuff like that. Maybe when you first started drinking black coffee, you're so bitter, but now you do it second nature. So it's an all or nothing response. It's either activated or it is not. You don't need to know the science behind this. I'm not going to question you how this works. You're welcome to learn it if you want. I'm not going to do that. If you are going to eventually pursue a career in the health sciences, I do encourage you to pay attention to this in your textbook, maybe watch a YouTube video. It is not fully relevant to the course in this case. I care a lot more that you understand an all or nothing and what an action potential and threshold is rather than how it works. Um, so same thing here with the speeds. Actually, no. I will do this one here. So the speed of an action potential here. So you have nodes on those axons, which allow the ions to pass through that myelin layer to the plasma membrane. Basically, those ions jump from node to node to node, and you get a quicker one. Boom, 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 boom. That's how it works. These are carried through neurotransmitter, and we're going to be introduced to a very famous neurotransmitter later in the course called dopamine. Now, this is the end of part 1. I'm going to continue in this video to part 2, though. If you feel this is too much already, pause this video, finish section 1, come back to it when you're ready to start section 2. And when I mean ready to start section 2, this is important. Have you read the textbook for this? Have you answered those questions? Section 2 is incredibly important, and it's used a lot in like test questions. And honestly, it's kind of interesting information once we break it down here. So if you haven't yet, do section 2, read it, do the worksheet, come back to this, and then start from here. So 3, 2, 1, start it. Sorry, before that, essential questions here. So we have 3 major parts of a neuron. What's the function of each part? And I want you to actually pause the video and think. Don't go in your notes. I want you to think. If you're not sure, guess. Pause the video now. 3, 2, 1. Dendrite receives the signals that are called those impulses. The cell body contains your nucleus, supposed to be nucleus, and your cell organelles. And the axon is what carries that nerve impulse from the cell to the other neurons and muscles. And then how is a nerve impulse similar to an electrical signal? Well, it's an electrical charge traveling the length of a neuron, and the impulse is a stimulus, right? If I touch you, if I poke you, if I pour something hot on you, if I do that, it might cause you to jump, right? Boo, nerve impulse. Reflex. A nerve impulse travels down the axon membrane. Remember that axon, the little highway we showed you there, which passes that impulse to the other cells. Those nodes that are between them, this sheath is insulated by the myelin sheath and lets that signal travel faster. It's kind of like a Japanese hypertrain, if that makes sense. Okay, it exists in its own little like environment, which lets it go quicker, if that makes sense. Same thing here, little quiz, just test your memory. I'm just going to give you 5 seconds here. Pause the video if you need to. What carries nerve impulses from the body to the other neurons and muscles? Dendrite. What are the gaps in the myelin sheath called? Nodes. What happens when an action potential is produced with a signal that is stronger than the threshold? For context here, I want you to imagine the difference between if I put your hand in hot water versus if I pour boiling water over your hand. So this one's important. Pause the video, think about it, give me an answer. Pause it now. 3, 2, 1. The action potential has the same strength as the threshold. So just because the signal is stronger, I've cut your finger off versus I've poked you, doesn't mean it's going to have a bigger action potential. Remember, it's all or nothing. It's on or it's off. Once that threshold is reached, it fires the signal. That said, a stronger stimulus can cause more neurons to fire more frequently, or it can recruit the neighboring neurons. So this is why still, more painful stuff is still more painful because it's traveling to other neurons. They're all firing the signal now. And instead of a do, they might be firing quicker. Do. So that's how we can interpret stronger responses, even though it's still an all or nothing response, if that makes sense. All right. And so now think about this. So if I were to have a person and they have no motor neurons, which one of these is true? 3, 2. They would be unable to swing a hammer. These deep cuts are sensory neurons, not motor neurons. Unable to breathe, that's an entirely different thing, which we'll talk about a little bit later. Feel a hot plate, sensory neuron, but you wouldn't be able to swing a hammer. Motor neurons carry nerve signals from the brain to the muscles and to the glands of the body, right? Conscience, decisions, and reflexes. Swinging a hammer is a reflex and or a conscious decision. Therefore, you can't do it. So it's voluntary and involuntary responses. So now this is section 2. This is part 2 here. Organization of it. P2, section 2. All right. So this is another famous. This is the first example of it. This isn't my picture. This is one I got off Google. But this is again the first ever human nervous system. It took 2 Oxford doctorate students like 3 months to do this. All right. So, couple of new terminologies here. Again, you should have finished up your first section here. All right. So, you have 2 different types of nervous systems. You have your central and your peripheral. And there's that lovely graph in your textbook, which I'll be referring to a little bit later as well. Okay. But think about it. I have my central, my brain, my spine, and my peripheral, my arms and my legs, if that makes sense. Brain, spine, central. Peripheral, arms and legs and other stuff is an easy way to think about this. The central one is mostly made up of interneurons. What's an interneuron again? It's that thing that travels the signal, right? So that's what coordinates all your body. That's what gets all the information, processes, and chooses and sends and receives responses. So you have your brain here. This is called your control center, right? It's your brain. You have a couple different things here. The cerebrum, the cerebellum, and the brainstem here. So the cerebrum, that's the big meaty part of the brain here, right? The cerebellum here, and the brainstem here. So really look at the graph here. Most of your brain is the central nervous system. Now, your brain has categories, right? Here's the frontal cortex, et cetera, et cetera. Yes, but we're kind of classifying it all here in one distinction. So your cerebrum is divided into 2 halves. You have your left half, your right half. They have different processes. You don't need to know that too much, but in case you're interested, your cerebellum has your balance, your posture, your coordination, and your skeletal muscles are controlled to make your motor skills coordinated and smooth. Again, just a couple definitions here. I'm not going to go into it too much here. Now, your spinal cord is a part of your central nervous system. Right? It extends from your brain all the way to your lower back. So basically your tailbone, right? And this is actually protected by your vertebrae. A vertebrae and a spinal cord are 2 different things, okay? It's like the, I don't know, if you ever had an avocado, right? The shell is the vertebrae, and then the nerve, the spinal column, is the fruit within. So this is your reflexes. So your central nervous system, any information you get is carried through the spinal cord to the brain, and it's responded with via a reflex arc, by involuntary reflex, or by a conscious decision, or both. It's your brain and your spine. Now, this is the graph I really like here. Okay. Now, your peripheral nervous system is broken up into 2 different systems. Your autonomous nervous system is broken up into 2 different systems here, right? So everything here falls under the peripheral nervous system except for the central nervous system. So your voluntary and involuntary responses come from your peripheral nervous system. Okay? That's the route that it takes. Now, in your involuntary decisions, you're not actively choosing to breathe. You're not actively controlling digestion right now, right? You're not making your heartbeat right now. You have no control over any of those things. Unless you're in the fight or flight response, right? You ever had that sinking pit in your stomach? Like, oh my God, what have I just gotten myself into? Congratulations, you've activated your sympathetic nervous system. When you feel that pit in your stomach, your body has stopped digestion. That's what that is. Um, it's it's cutting off the unnecessary things and focusing on survival, right? You've activated it. Whereas if you're just chilling right now, you probably activated your parasympathetic nervous system, which is just controlling your body when it's at rest. This is most of your active state. So your peripheral nervous system, right? Bundle of axons that control your sensory and your motor. The peripheral nervous system contains everything that's not the central nervous system. Now, in your somatic nervous system, this is sends information from external receptors, right? When I touch something, for example, when I hear something, when I taste something, when I see something, it sends that to your central nervous system, and those motor nerves relay information from the central nervous system to the skeletal muscles. Oh, crap, I see a deer on the road. I should probably brake. So voluntary movements and reflexes are part of the somatic nervous system here, okay? So reflexes and voluntary movements. Now, when I talk about swinging a hammer, that's here, right? That's there. Now, your autonomic nervous system carries your impulses from the central nervous system to the heart and to the other organs. So think about it this way. So your body responds involuntary. It's not under conscious control. Heart, beat quicker. Doesn't do it, right? I can't just force my heart to beat more. But if I have a dumbbell here and I'm going, ooh, 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 I'm doing some running or jogging or something, my heart's going to start beating a little bit quicker. It's a controlled thing. I can't force it to. I can just hold my breath. I can hold it forever. Eventually, my heart's going to start beating quicker. Right? Oh my God, we're short on oxygen. Heart, lungs. Right? It's automatic things. It's involuntary things. I don't control it. I can do things to activate it, but I don't control it. So your autonomic nervous system, two branches, right? Think about that big graph here. Splits up into two more. You have your sympathetic one, which is your fight or flight response. Easiest time to think about this, right? Okay, let's get some adrenaline in the system. Let's get our eyes fully dilated. Let's make sure we're hearing everything. That urge to pee, gone. You got to poop? No, you don't anymore. Ooh, we have a bunch of, a nice hearty meal going through. No, no, no. There's a bear chasing us. That's the focus right now. Everything unimportant shuts off. Everything important goes into overdrive. This is why your heart's beating so quick. Now, you can activate your sympathetic nervous response with something like anxiety. This is why an anxiety attack often feels like a heart attack, for example. Whereas if you're just chilling, that's your parasympathetic nervous system, right? If I'm chilling, watching TV, and we'll watch the Blue Jays game, that's what's activated in that case, right? I'll let you read that. Yeah. So, what do they control? Your central is your brain and your spine. It controls your reactions. Sorry, it controls your voluntary decisions. Reactions is a bad word there, and it sends commands to your peripheral nervous system. Whereas your peripheral nervous system is everything but your brain and spine. It sends the info to the brain, takes the commands and acts on it. It's your senses, it's your movement, and it controls your unconscious body activity. Keeps you running. So these have different tools, right? Your tools of the peripheral nervous system. You notice I've abbreviated it, right? PNS, peripheral nervous system. Well, that's split up into a few things, right? It's split up into the somatic nervous system, which sends your information to and from the skin and skeletal muscles. It's mostly involuntary, and most of those involuntary things are reflexes or reflex arcs. Your nerve cells, again, you have three of them. You have sensory ones, you have motor ones, you have autonomic ones. Your autonomic nervous system sends the information to the organs, right? Fight or flight response, involuntary nerve signals. This is what controls all of your organs. Okay. So, oh, I'm sorry. I meant to block this out here. You weren't supposed to see all this stuff on the bottom. So if you have scenarios which activate your sympathetic nervous system, right? Fight or flight, scary dream. If you have anxiety, you're gonna have to have those really terrible talks. Like, I do not want to do this. Again, think about that pit in your stomach. That's your that's your sympathetic nervous system. If you burn your hand, if you were scared, you see a deer on the road at nighttime, if you're being assaulted, that activates all this stuff. So we have essential questions here. When you stub your toe on something, what uh, what system sends signals of pain to your brain? Your somatic nervous system sends information to your peripheral nervous system, which goes to your spine. So looking at your diagram, why is the central nervous system not control the sympathetic nervous system? So why does the central nervous system not control the sympathetic nervous system? Why? Well, your one, it's not on the chart, but two, your peripheral nervous system uses your information from voluntary and involuntary actions, and it sends that information out. Okay, I can't just force goosebumps to form. I can't activate a fight or flight response. I can't force my heart to beat quicker or my pupils to dilate. I can do things that make my body do this, but that's because it's still activating that system. And then why does the autonomic nervous system control the sympathetic and the parasympathetic nervous system? Because these are done by the body in fight or flight. Fight or flight is either on or it's off. Once you're no longer in danger or your body doesn't think you're in danger, your parasympathetic goes back to the normal state. You're in the parasympathetic state for most of your daily life. That sympathetic nervous system is only for, again, when your fight or flight response is activated. All right, so that's part two. I know it's a lot. Before you move on to part three, you've been given a lot of definitions here. Your textbook, you should try and answer every question in your textbook now at this point. Go to the test part of your textbook too and see if you can answer that. Very helpful information. You're just quizzing yourself. None of that's for marks, but this is a lot of complicated stuff, right? It's understanding how this all works out. All right.